I'm going to explain how NFTs work on Ethereum and how the NFTs that you own are not actually stored in your Ethereum account. They're stored in smart contracts. And actually, the image, the JPEG associated with your NFT is rarely stored in the contract. It's usually not on chain at all. Usually, the contract will point to an external source where your image is stored. In the best case, the image is actually generated and stored entirely on chain. But more often, it's pointing to an external source. And in the worst case, that external source will be a centralized web server, in which case you don't really own the NFT image. You kind of just own a link because that server can be cut off or turned off at any time. So I'll explain how all this works and give examples of projects that take these different approaches. So in order to understand how NFTs work, we should understand a little bit about Ethereum itself. So Ethereum has a world state, and this is the same for pretty much all of these systems. You have a world state, and that's kind of it's a snapshot of the entire system. It's the state of all of the account balances, the state of all the contracts, all of the DeFi and NFTs and tokens. If you take a snapshot of all of that stuff at a point in time, that's the world state. Ethereum at any given time has just one world state, the latest world state. But the world state changes, obviously, whenever a block is mined with a bunch of transactions in it. Each transaction represents a change, some change to that world state. If it's a simple transfer of ETH, it's going to change the world state because one account will have less ETH after that transaction is performed, and another account will have more. So Ethereum has a history of world states, but at any given time, there's the current up-to-date world state, which is what we care about. And like I said, it has a bunch of all of the DeFi data, all of the NFTs and tokens. So it has a whole bunch of stuff in it, but it's actually somewhat simple because the entire state is simply made of accounts. And that's all there is in the state. But there's two types of accounts. There's externally owned accounts and contract accounts. Externally owned accounts are owned and controlled by some external actor, right? This is often a person like you that possesses a private key, which allows the externally owned account to initiate transactions and so on. And these accounts are really simple. You have an address, which points to some data associated with that account. And this is the state of the account. So the state of the account can change. The address doesn't change. And the state has, in the case of these externally owned accounts, the state is really simple. It's just a nonce and a balance. And the nonce is just an integer. It's just a simple number. It's basically counting how many transactions you've done from this account. So it'll start at 0 and then just increment. And the nonce is there to prevent certain types of double spending attacks, but it's just a simple number. You also have the balance. This is just your ETH balance. So this is just a number too. When you look it up on Etherscan or something, you'll see it represented in decimal form. So it might be like you have 1.156 blah, blah, blah Ether. In actuality, it is also an integer because Ether has a smallest unit. It's the way. There's like a million trillion way per ETH. And so while that ETH balance is represented as a decimal form, it's actually just, you have instead of 1.5 ETH, you could think of it like you have 1.5 million trillion way. So it's really just a big integer. But anyway, these two numbers are all that's stored in your account state. So as you'll see here, there's no token storage. There's no NFT storage. There's no here are your outstanding loans on Aave. All of that stuff is done by contracts, right? Contracts are another type of account. They're similar in some ways. They have an address that points to their state. In the case of these contracts, their state has nonce and balance, just like the other one, but it also has storage and code. So the code is fixed. When you create a contract, you'll upload some code to go with it. and that doesn't change, but the storage does change. So if you have a ERC20 token contract, for example, you'll have code that defines how the token functions. How do you mint new tokens? How does the transfer work? And if it's ERC20, if it conforms to the ERC20 standard, you'll have to implement a certain set of functions that give you some basic info like the name. I think the name's actually optional, but you'll have to have a transfer function so that other contracts can know how to perform transfers and so on. And then the storage, in the case of an ERC20 token, the storage will keep track of all of the holders. So the storage will essentially implement a little ledger, So just like entire chains in crypto perform the function of, keeping track of accounts and balances, this is basically what Bitcoin does. In the case of a smart contract platform like Ethereum, you can have a contract which does all that. So the contract can keep track of an entire ledger, and it can have custom code to define how it works. In the case of NFTs, it's similar. You have code that defines how the NFT works. You have code that defines, maybe how they're minted, where you go to get the image associated with the NFT, which I'll talk about in a minute. And you have the storage, and the storage will keep track of the NFT holders. So a certain address will be the owner of NFT index 123. And that's basically how it works. So here's an example of an NFT project implementation. So this is CryptoPunks. This is the contract. And so the contract code for CryptoPunks is really simple. Here's the code. Here's a better view of the code. So it's pretty simple. You have a bunch of basic functions to create the punks and to sell them and buy them and all of that. But you'll notice there's no image data in here, right? There's 10,000 CryptoPunks. So there's like 10,000 JPEGs, but they're definitely not in this contract. Instead, what you have here is a image hash. So what they've done is, here's the CryptoPunks project on GitHub. What they've done for this project is generate a whole bunch of these images for the CryptoPunks. And I have it here on my computer. So here is a huge composite image of all the CryptoPunks, right? If you zoom in, you see them. And what they've done is generated this giant image, this giant composite image, right? And they've taken a hash, a fingerprint of this entire image, and saved it into the contract. That's this hash here. So if you take, this is essentially one way to get the NFT images on chain without really having them on chain, because that big image is actually way too big to store on Ethereum itself. So what they've done instead is they take a hash of that image and put it on chain in the contract. And now they can share the image, on GitHub, wherever, and people can easily verify for themselves that the image that they receive is the correct image. And you can do that because you can take and download the image like I have, and you can hash it. So if I take a hash of the image using SHA-256, it's AC39 blah, 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 and that matches the hash here that's stored on chain. And here. And I can also, there's actually a function I can call image hash, and it's the same hash, right? So now you can take the image and, however they define the indexing to work, doesn't really matter, but assume the top left CryptoPunk is index 0. And then it goes 1, 2, 3, 4, etc. Now you can say, if I own CryptoPunks index 0. I know I own this one because I can download the image, hash it. That hash matches the hash that's in the contract. So boom. If anyone were to take this image and like swap a few CryptoPunks to make it look like they had a better one, then you could easily just hash that image and the hash wouldn't match, right? If you change any single bit of data in this image, the hash will be different. It won't match. Boom, boom, boom. That's how it works. And I think this is a reasonable approach to take. You know, in the absolute ideal case, it's nice to have the images fully stored on chain, because this way, the only downside with this kind of approach, like you can't tamper with it because the hash is on chain. You can't change the image. But the only thing you have to worry about is you have to make sure that that master image, that composite image, remains available and that someone's storing it for a long time. In the case of CryptoPunks, this image is it's pretty small. So I think that's a reasonable approach to take. In the case of CryptoPunks, it's pretty simple. There's no function here that actually returns an image, right? Again, you only have the image hash. There's no function here that's going to like give you a JPEG, and that's okay. Other projects though, they will implement this token URI extension to the ERC 721 standard. And the token URI will often return an image. Now, where that image is stored depends, but here's a sample implementation of this token URI function. This is from OpenZeppelin. It's just a kind of a boilerplate sample implementation for ERC 721. And this function will take a token ID and return a string. What it's doing is it's taking the base URI. So the base URI might be something like mynftproject.com/images/ that's it. And so that's your base for all of these URIs. This function will take and append the token ID for the given token you're interested in to that base URI. So if your token ID is 999, you call this function, it'll take mynftproject.com/images/999. And it gives you that string. You go to that destination and it'll return you an image or something like that, right? So a project that takes this approach is the Bored Ape Yacht Club. So these images are quite large. You definitely can't store them on chain. Even with CryptoPunks, it's prohibitive to store that data on chain. These are much bigger. There's 10,000 of them. They're much bigger. So you definitely don't want to store that on chain. This project takes a similar approach to CryptoPunks though, actually. Because what they've done is, instead of producing a composite image, right, they could have just done what CryptoPunks did. Take all of the Bored Ape JPEGs, like append them into the giant collage and hash that, publish that hash. I think the reason they didn't do that is because the images are a lot larger. So if you did a giant composite image of all of the Bored Apes, you would have a huge image. And it's just kind of, it might be prohibitive to download that and hash it yourself. And this approach they've taken accomplishes the same thing. So what they've done instead is hash each individual Bored Ape, JPEG, presumably in order, in some agreed upon order. It is in order. Look, C92, C92. So what they've done here is hash each image and then concatenate all those hashes together to produce this giant hash string. And now you've got this huge hash string consisting of 10,000 SHA-256 hashes. So it's 10,000 times 256 bits, which is quite a bit of data, but it's not crazy large. And you take that entire string and then you hash that. So that's what this is. this final proof hash. So that's a fingerprint. Basically what they've taken is take a fingerprint of every Bored Ape image, concatenate them into this giant composite image, kind of like that CryptoPunks collage, except this time we're taking just the fingerprints rather than the actual images. And then you hash that entire thing and you get this final fingerprint of the whole thing. Now this final proof hash is published on chain, and it accomplishes the same thing as in the CryptoPunks example, where you've captured this snapshot fingerprint of the set of all of the images. So now no one can modify or even swap order on any of this canonical Bored Ape, set of images, right? And then here they're just listing all the Bored Ape indexes and their hashes, and then an IPFS hash. I believe I have one here, yeah. So this is the IPFS hash, the IPFS link for that specific Bored Ape. So what they have here is they have all of the images actually stored on IPFS, which is a decentralized protocol for file storage. And so you can find the image. You can also call a function on the contract and get this image. This website is convenient because it's giving you the links, but if you want to be sure and actually check that for yourself, you can. By the way, here on the contract, here is that master final hash of that entire collage of fingerprints that we looked at. That entire thing is right here. So you can check that, be sure it's correct. You can also get a token URI. So token 1234, you can get the IPFS hash right from this contract. Go there. Now here, that IPFS hash is actually giving you, I'm not sure if you can read this, but it's giving a chunk of data that describes the attributes of the ape and also gives you a link to the image on IPFS. So rather than just giving the image, which, it's maybe you can deduce the attributes in the ape from the image, but it's kind of nicer to have them actually defined concretely here. So it says like the eyes are of sleepy type and the background is army green and so on. And then we have the image link here as well. And here's the ape. That's ape 123. Okay. So I think in the case of this project, again, it's a reasonable approach. The images are stored on IPFS. One thing to think about is the long-term storage. So they're being stored on IPFS right now, but is there some kind of funding to ensure that those images are stored there forever? Not sure, but they're pretty small images, so it's probably fine. Here's another project, Autoglyphs. So here a very different approach is taken. This is kind of the ideal case where you have all of the art, all of the images for this project are generated on chain, more or less. So in this project, you have 512 NFTs, and they have this cool kind of abstract artwork associated with them. And for this project, these NFTs are generated using this function. And this function is in the contract itself. Let's see. So there's a function here, draw. You can input a ID and it will produce this huge output. And so this is the function, the draw function, and what it's doing is it's taking a ID as input and it's turning that into a bunch of random data and then using that random seed to generate this resultant artwork using this function. and all of that's on chain. And when you perform it, so here's the logs for a transaction that actually generated one of these NFTs. This is autoglyph number 3. And the result of this transaction is this output in the logs. It's this huge string, right? So this was generated by that draw function. And if you take and render this collection of characters, which is also, this is calling the draw function with a different index. Again, you get a bunch of characters. You render it into a piece of art. So this is autoglyph number 3. If we call number 3, that's the source artwork for the image. Here it is again. And so this is kind of the ideal case because here the NFT source data for the artwork is actually stored on chain. And the reason they can do this is because it's a pretty small amount of data, right? Like if you were to try and take a Bored Ape and produce the JPEG data here, it would be, far too large. Like it couldn't be done. So, okay. Autoglyphs was kind of the best case. This Beeple NFT, I would argue, is perhaps the worst case that I've seen. So what you have here is, here's the Beeple image. This is a smaller version. The original is actually 300 megabytes, so it's quite large. But the way this was implemented is you have the contract and you have a token ID. And in this contract, the actual owner of this $69 million NFT, what they really own in that contract is they have their address and then a token ID next to it. So basically, the contract has this record saying your address owns this token ID. And that's kind of all they have. But if we check that, so here's the contract. Now I've already done it, but there's a token URI function. You enter that ID for the Beeple NFT, and you get this token URI in return. Now, if we actually go to this token URI, it says invalid path IPFS/IPFS should be, basically it seems like the string might have been formatted wrong, which is, I don't know if that's actually a mistake or if I'm misunderstanding something, but the actual function on the contract, the thing that's keeping track of you owning this NFT, the $69 million NFT, that function seems to return a slightly misformatted IPFS link, which redirects and gives you this correct one. So it's whatever, it's fine. But it's a bit sus. Anyway, if you take this, the data here at the proper IPFS link, I have it here in VS Code, so it's a bit easier to see. You have a bunch of data. It has the title of the NFT. It has an image URL, which is great. It has a description. So anyway, again, the contract has if you own the NFT, the contract has your Ethereum account, points to an index. That index in another function on the contract will return an IPFS link. That IPFS link will give you this chunk of data. The chunk of data has in it another link. It has in it a bunch of data describing the NFT and another link. And that link will give you a JPEG. And in the case of this NFT, the IPFS link is on what I think is a centralized domain. So if this makersplace.com goes down, I'm not sure if this link will still work, but I could be wrong on that. But that's how the Beeple NFT, and I'm presuming all of the I think it's Sotheby's that sold this. I think this is how they implement all their NFTs. So, tis what it is. Okay, here's another example, final example. So, CryptoKitties. Here's the CryptoKitties contract. So this NFT project, it doesn't have the images stored on chain, nor does it give you a link to IPFS or similar decentralized service for that image. And, you know, unlike Autoglyphs, where the rules for generating the image are known and transparent, here they're not. So in the case of Bored Ape Yacht Club, they generated all of those images ahead of time and then produced the hash and published the images, and then you're all good, right? In the case of CryptoKitties, because the kitties are continually breeding and you're producing new additions, that the images are not all generated ahead of time, right? They can't be. And the rules for how the genetic traits of a kitty translates into the actual image, those rules are not published. So if the CryptoKitties server that's actually generating the images for a CryptoKitty and its genetics, if that server is to go down, maybe they just cancel the whole thing, then those subsequent CryptoKitties that are born after that point, we won't know what they look like, right? Because we don't have the rules to determine how the genetics translates into the actual physical attributes. So, because the way the CryptoKitties work is you'll have an ID, and similar to the other projects, what the contract actually keeps track of is the mapping of an address to an index. So, CryptoKitty 123 is owned by a certain address, and so on. And what they also have here is the contract will tell you who owns what index, and then you can check the CryptoKitty index here and get its genetics. But this genetics thing here is really just a number. It's a big number. And again, the mapping from that genetic code to the actual image, which is kind of what we care about, that's opaque, right? You can take and look up a specific CryptoKitty on their website, right? This is Kitty 1. Maybe I should try 1. Right, so on the contract, you can check CryptoKitty 1, you can get its genetics, you can get its owner up here somewhere, and you can go to their website and you can actually get the image and the, whatever else, the features and so on. But yeah, like I said, if this website goes down, then all you own really is an index with this genetic code here, which doesn't mean anything without the website, right? So yeah, I mean, that's how the NFTs work more or less. There's this whole thing is called NFT provenance, by the way. Like all of these contracts, they keep track of an index for the NFT. So in every case, what you own is at least the index. In the best case, like I said, in the case of Autoglyphs and others, the image is generated on chain. So you like really own that in a sense. It's recorded. It's not going anywhere. But in, the more common case, you have like a hash, you have a fingerprint of a collage or something. And then the images are saved on IPFS somewhere. That's a pretty good approach. In that case, you still have to worry a little bit about long-term storage, right? Like if, great, the image is on IPFS, but who's paying for that storage long-term, right? And yeah, in the worst case, what you have is you just have a link. Like you have a contract, it says you own NFT 123, but then all that you have aside from that number is a link to a centralized server that can go down, whatever. So then you kind of just own a link. So anyway, that's how it works. Let me know if you have any questions. Next video will be on the EVM, so look out for that. And thanks for watching. See ya.